something about the soil. It was about, it was geotechnical. With the engineering, I felt like I could actually touch the soil. And then after I got into a lab and then I got to go out on drill rigs, it was so much based on experience and what you have seen and how that soil behaves. It's not going to be the same every single time. And so there's always a challenge with it.
It's a great industry for people who like new things that pop up underground and who can deal with changes as they happen. So it's rewarding and always full of new things.
We definitely get the opportunity to be designer and builder all in one, and not everybody has that offering. Not every engineer has that ability in the pathways that they choose.
It's very satisfying. Most of the work we do is never seen, but it's still satisfying to drive over a bridge knowing that I've had a hand in constructing it, or looking at a high-rise building, any beautiful building, knowing that deep below the ground is my contribution to that structure. It's just a very satisfying feeling.
It's a very big industry, so you have a great opportunity to advance and to be able to move forward in your career and become valuable to the industry or the company you're working for.
What I like about soil is that it's sort of a mystery below the ground, right? You only get to see a little bit of it at a time and then try to interpret what's going on. So it's sort of a puzzle that you're putting together.
Good afternoon, everyone. This is Sai Sindhu from DFII India office. I welcome you all to DFII India Groundwork 2023 Webinar 3. So before we start the session, here are a few instructions. Recording of this webinar is prohibited. Participation certificates for the students will be mailed in approximately 2 weeks. And the online webinar recording will be available on DFII India YouTube channel in approximately 2 weeks' time. So you can ask your questions anytime during the presentation in the box, ask your question in the live Q&A field. So the questions will be taken during the Q&A session after the presentation. So now it's my pleasure to introduce Mr. Venkatesh Karmuri, today's session moderator, is Director of M.I.E Group. Mr. Venkatesh has 15 years of experience in field of civil engineering, which includes designing and execution of several national highways, soil investigation, and foundation recommendations for bridges and retaining structures. He has worked as design consultant, quality engineer, project manager, which includes design optimization to make most cost-effective and value engineering solutions, with the knowledge in geotechnical engineering in India and Middle East regions. We welcome you, sir. So now I request you to take the session forward. Thank you.
Thank you, Sindhu. Good evening, everyone. It's my pleasure to be a moderator today. And now I invite Mr. Khan to start over his presentation. But before that, we just want to let you know that there are 450 registrations done for this webinar from 20 countries, and we are happy to see the growth in and importance given to the geotechnical industry. And we appreciate everyone who is participating in this webinar. And I just heartily congratulate Mr. Khan for accepting this request from the DFI, and we request you to start the presentation on D foundation for construction for modern bridges. And this will go in phases, starting with the introduction of the speaker and going with the presentation, and we will have Q&A session and the closing remarks, followed by a short detailed overview of what the events coming up. And I welcome Mr. Khan again, and I just want to introduce Mr. Khan to all the audience. Mr. Ekhlaq Ahmad Khan is the current Chief Engineer Manager at Engineering Design and Research Center at L&T Mumbai office. And he holds a Bachelor of Engineering in Civil and Masters of Engineering in Structural Engineering from University of Mumbai. And with his professional experience of 17 years, he was expertise in doing designs of special steel bridges, structures, developing construction methodology schemes for deep systems and enabling works for several flyovers and bridges, viaducts, metros, whatnot. And he holds the experience in construction engineering, and he's a member of Institute of Engineers in India. And he has authored many papers in interesting construction engineering problems, deep foundations, and challenging jobs in all the sites. And I welcome you, sir. And we request you to take it forward from now on.
Thank you, Mr. Venkatesh, for this introduction. I hope my presentation is visible to all.
Yes, it is visible.
Yeah. Very good afternoon to all. I welcome you all to this presentation talk on deep foundation construction for modern bridges. What you are seeing on the screen are a few modern iconic bridges built in India in the last decade, be it the Bandra-Worli Sea Link, Mumbai, the Signature Bridge at Delhi, the Zuari Bridge at Goa, the Bogeybill Bridge at Assam, the third Narmada Bridge, Bharuch, the second Hooghly Bridge at Vidyasagar Setu. I'm sure you must be wondering how all these type of tall pylon cables and all superstructures have been built. But have you ever thought about the structures which are hidden beneath, how they were built? And what if you are asked to construct one of such other structures, what will be your strategy? Well, in this session, we'll try to understand, how concepts are worked out to solve these kind of real-time challenging problems with the help of two case studies out of these projects which I have mentioned. One is the Signature Bridge at Delhi, and the other one, third Narmada Bridge at Bharuch. So the case study will have a brief of what is the project, what is the substructure, the foundation, the superstructure, what are the ground conditions. And then we'll try to understand how the site is spread out, what is the site layout, what are the challenges there. And we'll try to work out some options possible to solve that problem. And finally, how that problem, whatever solutions we have found out, how it is applied at site, and what is the conclusion that we can make out of it. So let us quickly have a look at the terminology used in bridges for those who are new to bridge engineering. You can see here, let me take a pointer. The surface on which the vehicles ride is called the deck. It can be in steel, concrete, pre-stressed. And if it's a long span bridge, generally what I've shown you now just recently, if it's a cable stayed pylon bridge, then the load will be taken up by the cables and there will be a balancing spans behind. And then the load will be transferred to the substructure, maybe the pier cap, pier, and the foundations. There could be different possibilities of these foundations depending upon the contract conditions or environmental regulations. You need to maintain the certain foundation levels. There could be different possible situations. The first situation where you have, rock and you have large forces to cater. So you may have a raft foundation at some good strata. Or you may have a pile group in which the pile cap is lying in the waters. It may lie in the intertidal zone, or it may lie in the tidal area. Or you may have a situation where the pile cap is above the water. Or if you have scoring, if you are sure that there may be some difficulty in future, then you may need good embedment. For heavy loads, you may need well caisson. Let us start with our first case, which is the cable stayed bridge over River Yamuna, the Signature Bridge, the iconic bridge, which most of you might be aware of. It is situated in Delhi, Wazirabad. It is 600-meter downstream of the existing barrage. Its length is main bridge is 575 meters. The main cable stayed portion is 251 meters. And the overall deck width is about 35.2 meters. And it has got one of the largest expansion joints, which is of around 1 meter. And the most state-of-the-art structure is the pylon, which is about 150 meters tall. Let's see the superstructure. The superstructure consists of the deck, the riding surface, which has got main girders and cross girders. It is held up by the cables, stay cables, which is supporting the main spans. And the load is taken up by the two legs of the pylon, which is in structural steel weighing around 7,500 metric ton. And the entire load of this main span is balanced by the balancing backstay cables, which transfer the load further to the foundations, where we have a special pendulum bearing, which is allowing the movement of the bridge of that 1 meter, which I said. Now, this project is a classic example of how every foundation in a project is unique. If you see the strata, it is from P1 to P26. The rock strata is varying. It goes up and then it further goes down. So depending upon the loads which it has to carry, since this is the main span, the loads are heavy. If you see from P1, there is well foundation. Then again, you have an open raft. Then for the main pylon foundations, there are two separate foundations. And then again, you have for the balancing spans, one raft foundation and then well foundation. And for the backstay, you have again a big, large diameter, 17-meter diameter well, which is a hybrid kind of foundation, which has got pile as well in it. The main P3, P19, and P20, these are the foundations which are critical, which are lying in the water, which are always subjected to floods. So the main pylon foundation is 23 meter in diameter, and it is about 18 meter resting on the rock below the soil. And the other adjoining balancing spans are P3 and P20 foundations, which are of about 7 meter diameter and having a pier diameter of 2 meter. And in the extreme left of the image, you can see some structure C32, which is the approaches. And you'll be surprised, beyond C32, there are pile foundations. So within a location of around 600 meters, you have all types of foundations. That is the challenge that civil engineers have to face. Let us see the ground conditions. Here, mainly the subsoil strata is generally homogeneous and comprises of mainly two types of layers. The low water level during summer season is around 202, and the high flood level is around 209, which is used in the permanent design. And then the observed ground level on the right-hand side from P19 to P26 is around 206, which is high ground, and P3 to P1 is around 203 meters. The first layer is of sand, which is about up to 194 RL. And then you have sandy silt up to 190. And below that, you have a typical of a Delhi soil, which is a moderately strong quartzite rock. So the challenge is to construct the foundations P19, 20, and P3, which are open raft to be founded on rock mid of the river. So we need an efficient ALS system. There are certain requirements of every ALS system. In this particular case, it needs to be a simple and economical solution. It should facilitate a stable excavation with minimal obstruction to the foundations. It should provide an efficient groundwater cutoff. It should contain the ground movement within the permissible limits, and it should be easily dismantleable. The real challenge is here, if you use any system, it has to rest on rock. So installation in hard rock is a challenge. What are the options possible? What are the solutions possible? The easiest solution is always to have an open excavation. This is the most economical way to build a permanent open foundation. But there are certain limitations. If you see the area is very near to the edge of the river, so always there is a risk of flooding. And since the size of foundation is huge, it is around 23 meters in diameter. So if you excavate the entire area, it's a huge excavation. And doing such excavation in an ecologically sensitive area is restricted. And when you do such excavation, a continuous dewatering and backfill expertise is required after the construction is complete. And once you are doing open excavation, you need to stabilize the slope. So you may need a larger area. So that right of way also is an issue. So what is the other option possible? Maybe an excavation and lateral support system would be a better solution here. So cofferdam with sheet pile will have certain advantages, like it will allow excavation and construction of structure in otherwise very poor environment. It may provide a safe working environment. And then if you are using sheet piles or any other similar structure, it may be easy to install and remove later on, and so that the material can be reused in other projects. Now, if we are decided that we'll use the structural steel sheet pile cofferdam, then there are always different sizes and shapes possible. So which is the best shape which we should adopt? The first option is to have a rectangular cofferdam. So the issue with this is if you do a combined cofferdam, rectangular cofferdam of such a huge size, any problem anywhere in the structure will lead to stoppage of the work. Just imagine if it gets flooded, the entire operations will be stopped. Okay. So now the other option remains as octagonal cofferdam and a circular cofferdam. Here in octagonal cofferdam, you get good optimization, structural optimization, where you'll get reduced quantities of sheet piles as well as you'll get reduced quantities of whalers also. And the further better option is having a circular cofferdam. But the radius that is required here is 12 meters, which is very challenging to achieve at site actually. You need a skilled people, skilled team so that they can achieve perfect shape. Otherwise, the behavior which you have assumed in the analysis may not be the actual at site. So you may have problems later on. Although the circular cofferdam is the best economical solution in terms of quantities. So technical commercial review was done. And finally, it was decided that for P19 foundations, a 28 meter by 28 meter, 2 isolated open foundations will be done. And at P3 and P20, we'll have 12 meter size rectangular cofferdams. Now, ideally, a sheet pile or any retention system should have good embedment in the soil or in the rock. But when you are dealing in rocks, it is very difficult to penetrate the sheet pile in rock. So here the insufficient embedment depth was a challenge. Like when you install the sheet pile and when you excavate layer by layer, strut by strut, then when you reach at the bottom, when you have to install the last strut level, there is a very good height which is unsupported. So there is always a risk of the base shear leading to instability as there is no passive resistance available. So we have to find a solution for this. The solution was, an innovative idea of using a toe pin. What is toe pin? Toe pin is nothing but, a pre-drilled pile, which is driven initially when we are driving the sheet piles. It is driven on the face where you have to generate the reaction resistance. It's a 273 mm diameter steel casing provided drilled at the top, and then ISMB 200 section or any equivalent section which is sufficient to take that reaction is lowered, and then concreting is done. So when you excavate layer by layer and when you reach this level, you need to excavate a greater depth and you have a resistance, safe resistance to carry out the works. So while designing such a cofferdam, there are certain considerations which must be taken care. Like a good understanding of the subsoil conditions is very important. The parameters used in the analysis are very important. Otherwise, you may not get right picture. You may get forces which may not be in line with the actual observed forces. The understanding of the stage-wise excavation is again very important. What are the different steps? What forces will be generated? What are the unsupported conditions? All those need to be idealized properly. And stability calculations against overturning must be done. If there are chances of scoring, it must be taken care. And especially when you are founding on rock, the stability against the horizontal shear at the tip is very important. You must check whether the system is stable, whether if it is properly socketed in rock or not. And if you are, there are other certain forces like, ice, wave, water current, besides the active and earth pressure and passive earth pressures. There may be equipments which may be used for excavation moving around your structure. So it may lead to certain additional surcharge, which needs to be accounted due to heavy machinery and heaving of material. If you excavate, the excavator may heave the material just besides the sheet pile or any other retention system. So that also must be taken care. Once you have designed, once you have analyzed and you have checked up the section, you have finalized the section, it is very important to communicate the construction stages, the process to the construction team, so that they carry out the construction in the desired way and the behavior of the structure and the performance of the system is as per the design requirements. So this is how you have to put the stages on the drawing board. The very first stage would be clearing the area, leveling up the ground. Then you need to drive the sheet piles. And then you need to put these, pre-drill these toe pins before start of excavation. And then you need to define up to what level you need to excavate and then fix the first level. Similarly, moving on, define the excavation level, fix the strut level, define the excavations up to which you have to go, continue, and then finally carry out the construction of the required foundations. And then again retrieval. Once the structure is complete, you need to retrieve all these elements. So you need to define the retrieval scheme. You need to give backfilling, at what height you need to refill, at what stage you need to dismantle the strut and veiler system, step by step. Let us see how the construction was carried out for this particular chosen scheme. The very first step is to provide a guide frame. Wherever you start, carry out the survey, provide the guide frame. Then drive the sheet pile using suitable capacity vibro hammer. If possible, try out a test depending upon the selection of the vibro hammer, whether it is able to provide that resistance for the desired length of sheet pile, for the desired weight of liner to be driven into required length. And then pre-drill this toe pin or the liner, which will be drilled up to the required depth below the rock, and then the structural section of maybe ISMB 200 or as per design can be lowered in, and then concrete can be done so that the additional layer which is required at the bottom can be avoided. Then whenever you start excavation, before that, a network of drainage pipe needs to be installed, boring needs to be carried out. The water table in the area should be lowered down so that you can, if required, lower a suitable size equipment, excavator inside, and then excavate up to the required level as defined, and then fix this first strut level and continue further till the founding level is reached, and keep on carrying out dewatering of the area so that you have safe conditions around you. And once the rock is reached, you need to maybe have to go further down up to the required level for the structure. Here in this, you can see the pre-drilled toe pins are supporting the sheet pile and were helping the structure to be built in a safe manner. And this is how the P19 foundation, which is a raft of 23-meter diameter, was cast and completed. Once the foundation is complete, the pier shaft is built. In this particular case, the pier shaft was 5.5 meter and the pier cap was 10 meter. And from aesthetic requirement, a dummy wall was created up to bottom of the pier cap. So some important considerations which are to be taken care while designing this system is that, special equipment is required to carry out these works. You may need a pile driving hammer, a vibro hammer, or an impact hammer, depending upon the soil conditions. You may need a suitable, sufficient crane capacity. By rule of thumb, the crane boom length should be twice that of sheet. It should be twice that length of sheet pile or maybe the liner which you are going to use. In case you are operating in waters, you may need barges. And guide frame is very important. Before you start the sheet piling driving work, you should have your guide frames templates in place so that the alignment is maintained, the profile is maintained. And these sheet piles are relatively expensive. So we must try to reuse them as much as possible within the project so that it becomes economically viable. And it's a skill-based work. So meticulous planning is required to get productivity. You need skilled labor They should not rush into driving so that the interlocks of the drives of the sheet piles and the liners, whichever you are providing, are maintained and do not come out so that there is no leakage and plumb is maintained. And then you should have always a dewatering system in place so that flooding never occurs at your place. Now from the case study one, this particular bridge, we can make some conclusions. We can say that a good understanding of site geotechnical profile is must during modeling and analysis of any ELS system. We must have the parameters from the lab test to get the behavior in right fashion. In this particular project, an innovative concept of pre-drilled topin was successfully incorporated in the design and construction to minimize the cost and provide a stable support to the sheet pile cofferdam. And this technique is adopted and it has given a new level of confidence in the use of toe pinning for sheet piles, especially in rock, so that we can avoid ground anchors as well. And this technique may prove to be best solution for carrying out huge excavation works in rock in future. Let us quickly now see our second project, which is the extra dose cable stayed bridge over river Narmada, Gujarat at Bharuch, which is near Vadodara. Let us understand what is the project. You can see here three parallel bridges. The far off bridge is the first Narmada bridge built in 1979. It is also called as Sardar Bridge. The next bridge, second bridge, is built at 29 meter downstream of the first bridge. It was built in 99. And the third Narmada bridge, which is around 100 meters downstream of the second bridge, was built in 2017. It's an extra dose bridge. Talking about the substructure and foundations, the entire bridge is of 1.5 meter diameter piles of a totaling around 132 numbers with the average depth of around 50 meters. The pile cap is of 13.2 by 15.5 and 2.2 in size, and it is lying below water. And then the lower pylon is Y-shaped with a height of around 30 meter maximum. And the two pylons, lower pylons, are connected with a diaphragm, which is of M50 grade. And the upper structure is called upper pylon. The deck is of 20.8 meter with maximum segment weight of 130 tons, precast segmental box girder. And the spans are totaling up to 1.344 meters, 1344 meters, which is around 1.3 kilometers, with two balancing spans of 96 meter and 8 spans of 144 meters. Let us see the ground conditions here. The topmost layer is silty sand, which is around 4 to 5 meters. It is very weak. It has got a SPT value of 5 to 11 only. Then you have second layer, which is 30 to 34 meter, but the SPT value ranges from 35 to 96. So it is a harder clay. There is a difficulty found while driving the sheet piles, even piles. And then you have third layer where the SPT value is more than 100 and there is a refusal. And the bottommost layer is sandy silt with hard clay, and the groundwater level is usually at 2.8. Let us see how the site is spread out. As I told, the farmost structure is bridge number 1, the bridge number 2, and 100 meter downstream is the bridge number 3. It has got mainly 4 critical foundations, which pose a real challenge for construction. The P1, P2, P3, which are in the mid-river, and P4 is at the edge of the river. So there is always possibility to manage these foundations, by carrying out some island protection works. But these 3 foundations, which are in the mid-river, are subjected to daily tidal variations. As you may be aware, Bharuch is near to sea, so you have a daily tidal effect of low tides and high tides, and there is a variation of around 3 to 4 meter maximum. So again, the challenge is to construct the foundations P1, P2, P3 safely with a suitable ELS system. Again, here the requirements are different. It certainly has to be simple and economical. It needs to facilitate a stable system for water retention with minimal obstruction to foundation construction. It should contain the high daily tidal pressures, and it should be easily dismantleable. And the biggest problem is it has to sustain the deep waters. It has to retain a good depth of water. So what are these options possible here? Again, similarly, the way we approached our last problem, the first option could be doing an open excavation, where you can just simply excavate. And then since the foundation P4 was at the edge of the river, it was possible to carry out this excavation there. But any other locations, there is always a risk of flooding. A continuous dewatering system is required if we adopt any open excavation, and you need sufficient right of way. So in this case, only P4 was the location where we could adopt this kind of solution. Another innovative idea was planned, wherein a precast hybrid shell was proposed. A tub which will be cast at the shore and it will be floated to the location. It will have a base of concrete and a upper portion of steel to retain the additional waters. And it will be floated from the shores, brought to the location, lowered onto the piles on brackets. The piles would be sealed, and then it will be dewatered to create dry conditions. And then the reinforcement in pile cap could be carried out. But then it was found out that commercially this solution was not viable to carry out for only 3 foundations. There were many other foundations. Carrying out this solution was not economical. So again, most economical way was to build a cofferdam with 2 different sections, one with circular liners of 1.5 diameter and other with U-type, J-type sheet piles welded face to face. As I said earlier, construction stage analysis plays a very important role in designing the such structures, wherein you have to understand each and every level of construction. So in this particular case, once the sheet pile or any other retention system is completed, then you need to dewater it. You need to place the first level of strut, then further dewater it up to the required level, and then place the second level and carry out similar stage by stage fixing of reinforcement and this strut vela arrangement and dewatering up to the required depth. But here the challenge was to dewater below the second stage of second level of strut was really difficult because of the high water head. If you understand through this sketch, the pile cap was lying in the mid-level of high tide and low tide. To dewater, to ensure that you have sufficient dry conditions to do this, you will have a water head, you will have a pressure head here. This pressure head created a huge bending moment. In case of P2, where the retention was more than 15 meters, it was not possible to fit in any section here, any suitable ELS system here. So a simple idea came to our mind, wherein it was thought that why don't we backfill this entire area to permanently cater the differential head. So locally available soil was filled in, and then we were able to reduce the bending moments up to 35% in case of P2. Let us see how the stage-wise schemes were defined. The first stage, the dewatering is done. First level of strut is fixed. Then backfilling is carried out up to the pile cap bottom. And then if any leakage is there, dewatering is carried out, and then PCC is done, over which the pile cap is cast. From the analysis, we get the forces and suitable strut vela system can be designed. It is very important to note that the data that is available with you at tender stage must be verified, because at times it happens that when you complete your design and you release the design drawing, you get to know that the observed levels are different. Then your design does not fit into that requirement. Similar was the case here. The tender stage data which was provided was indicating a river bed at 2.5, but actually at P1, P2, and P3, it was much varying, and the depths were ranging from 11 to 10 meters. So the depth of sheet pile requirement also changed. It went up to 22 meters. So you have to be very careful always verify the data, authenticate it, and use it. Now let us see the construction. As discussed earlier, the P4 was at the shore and it was possible to carry out the construction by making a bund, dewater, secure the embankments, dewater to the required levels, create dry conditions, and carry out the pile cap construction. In case of pile construction in mid-span, it was done using the equipments like spud barge over which a rig was placed, and the spud barge was moved with tugs. The basic steps involved in the piling were carrying out survey, positioning of the barge, liner driving with the vibro hammer, pile boring with the suitable rig, then cage lowering, and finally concreting. So once the pile caps is to be started, before that, all the permanent piles are ready. Before that, you have to start cofferdam. So the very first step of construction of cofferdam is carrying out the survey, positioning the guide piles, positioning the guide frame, ensuring their alignment, and then driving the sheet piles using suitable vibro hammer, and continuously check the pile cap verticality. And once one stretch of wall is done, you can always move on ahead by moving the guide frame. We need to define the steps. It is important to note that at the beginning, you should always leave some space to start with, so that once you complete all the directions, you are able to adjust your errors while closing the cofferdam. At the corners, you can use the corner sections which are readily available. In this particular case, two sections were used. One type of sheet pile was face-to-face welded hat type, and the other was 1.5 meter diameter liner. And they had specially made end connections to make the corner bend. One of the important steps in this is you need to keep gates so as to ensure that till the completion of cofferdam, the inside and outside water levels are same, and you don't experience that differential head before completion of your cofferdam. So here temporary openings were kept, liners were raised, and the water was allowed to move in and out till the entire work was complete. Here you can see some of the piles were raised up, water was allowed to move in and out. Backfilling was carried out using the sandbags, which are weighing around 1.5 tons of locally available soil. Once the backfilling was complete, the last level strut was fixed and the cofferdam was intact. Then dewatering was carried out, dry conditions were achieved, and PCC was laid. Piles were chipped to the required levels, and reinforcement fixing was done. Here you can see there is very minimal leakage and dry conditions are available. And here how the liners with circular liners had the connections, you can see. Once the pile cap is complete, the lower pylon is built. The concrete is done using barge, having transit mixers placed on it. In this particular case, 3 transit mixers were used. They were used to pump the concrete. At times, the cofferdam may have to serve dual purpose. It may be required to support the other supporting enabling works also. So in this particular case, the pier table was supported on the cofferdam. The liners were used to take reactions. And again, once the work is complete, you have to again same way define the retrieval methodology. The Liners are driven, gates are opened, water is allowed to move in and out, levels are maintained, and then only the strut vela system is removed. So with this particular case, we can conclude that the retention system for the project were designed based on the geotechnical and groundwater control requirements. It was evident that overall reliability of the structural performance in such cases is very sensitive to soil stiffness parameters. Apart from localized problem of leakage, no significant deflection was observed. A very smart and simple use of local material led to economy in the project and ease in construction. And it is foreseen that recent expansion in the use of sheet piles and circular sheet walls in this country in different ways, along with the use of local resource, will increase appreciation of the potential of this technique. So with these two cases, let me just quickly summarize. The first case where we saw how we can establish a cofferdam system in rock also using an innovative idea of toe pin. And depending upon the site condition, we can decide which is the best method. And in case 2, where the situations were different and the water depth retention was the main criteria, we had used our local resource and we were able to contain the structural requirement of the quantity to a very good extent. And we could find an effective, cost-effective solution. This is all. We can have now questions, if any.
Thank you, Mr. Khan. And I have come across few questions during the presentation, which I want to keep it in front of you. Mr. C. Anabalgan, he is asking that is this toe pin in the secant pile system to avoid water ingress?
The toe pin is provided to provide that base resistance, which is not available due to lack of insufficient abandonment of the sheet piles.
Second question from Mr. Mohan Mishri. How much horizontal deflection of sheet piles was permitted at the top of the sheet piles?
See, the sheet piles are similar to our piles. See, the requirements of deflections remain the same as per the IRC requirements.
Okay, next question from Mohan Mishri. But the integrity tests and load tests were carried out for the piles?
See, these are not load-bearing piles, basically. Sheet piles are retention systems. The critical thing is lateral loads. So no such test is done usually here, unless in case of liners, where it is indented for the vertical load also, you may carry out.
But sir, I just want to ask you a few more things as well from my side. Being the country is more into Make in India concept and also fastly driven in transportation and also in marine sector as of now. Sheet piles are predominantly used, which we are also seeing. It's a fast pace of doing the projects of large scale in a very short span. What is there any literature what it can be given to structural engineers as well? Because we work hand in hand with structural engineers, all the geotechnical engineers, and we work in a phase that it must get it integrated, because most of the designers doesn't have a field knowledge and field engineers doesn't have a design knowledge. So do you think how this gap will be bridged, and how can we bring every engineer who is working in this field and designs to one single platform? And because we are addicted to use IS codes and as well as BS and sometimes ASTM as well. But that is not relevant, I feel, to Indian conditions. So how do you guide in such cases?
Yes, certainly the exposure to such technology is very important. People should be aware of what is being done around, what is the industry heading towards, okay, what are the best methods people are adopting. So they should try to connect to such people, connect to such literature, such resource, and try to see that wherever they get opportunity, they should try to introduce such technologies. They should not be scared of any, lack of precedent. So,
yes,
in fact, I would rather recommend that in US, people are using these sheet piles and other such similar structures, even for permanent retaining walls. So we should try to influence, try to, guide our, maybe the clients, maybe the government, maybe the authorities, who can build up such, requirements in their projects of using such sections. And certainly contractors can push in also, help them, to give that confidence for that use of these materials.
A question from Mr. Srikanth. Can you elaborate on the design of topin, the criteria of the diameter or height, how it is arrived?
Yeah. See, as I said, when you excavate at the bottom, the bottommost excavation will be of a larger depth. So you need to find out the shear that will be generated in unsupported conditions. And certainly it may have some, stability issue also. So what is the per meter shear generated? That you can always find out as a retaining wall. And then for that calculation, depending upon your sizing of your sheet pile, you can decide the spacings of your sections, and you can structurally design that section to carry out, to take the shear, basically.
So you are telling it's basically like a grout plug, which need to be designed in lateral load, not
Yes,
not any.
absolutely.
So
Yes.
okay. So what recommendations do you do for this toe plugs? What type of materials you recommend?
Generally, the construction also needs to be seen. It should be faster. So DTH machine is used to do this, pre-drill this 273 mm diameter. That's why we have decided 273, because it's a very less than 300, easily, fastly you can do. And you don't need to do it at every meter. Like in this case, it was 750 mm AU section. So it was done at 1.5 meters. So certainly you can do at a much faster pace. And you need to just put a plug up to the required embedment as per the calculation. We don't need a liner till the entire depth of the soil. So you can always economize in that case.
And also in water ingress locations, wherever you have come across in high tide levels, basically in all the rivers, because Indian rivers are too much aggressive, and we have flash floods come across the country. So how you are seeing that dynamic to this type of steel solutions? Because people who are going down, they need to feel safe as we are, as the designers. So how do you correlate with that, sir? Do you think that's practically possible to achieve? Because the dynamics of Ganga is different with Brahmaputra, Brahmaputra is different with Narmada, and also soil conditions as well. So how do you take it over, sir?
Yeah, certainly this structure is affected by the soil conditions, but not by the water conditions actually. Because if you select the right section, if it has got right interlocks, if the driving technique is proper, you will not face much of a problem actually. There are adhesives available which you can put into the joints, which are hydrophilic, which when they come in contact, they swell and they prevent all those pores, all those cavities, they close all those cavities, and you can perfectly have dry conditions, even with a retention of 6 to 7 meters of water, which we had in Narmada. So it is very, very much possible to get a perfectly dry conditions, even in river also.
And limitations on deformation criteria, sir. Is it any specific code or standard for that?
Unfortunately, there are not clear guidelines regarding this. So, but as a designer, you have to be always careful, and you have to ensure that any untoward movement, settlement around your area must be taken care, must be found out the reason, and then locally work out a solution. Because here the skill is very important. Driving the sheet pile to the profile, to the alignment, interlocking them properly, closing the corners properly, joints properly, will ensure success of your system.
Question from Mr. Praveen. Considering dynamic loading and stability, can the group of piles Can a group of piles have better piles instead of typical horizontal piles in edges and corners?
I think he's referring to permanent pile
groups. Yeah.
Yeah, certainly. I think it's not the topic, but maybe just for his understanding, it depends on the load which it has to cater. If it is a berthing, platform, it may have those tapered piles. And if it is a navigation span where there are risk of barge impact or ship impact, certainly the designers will, take into account all these forces as well.
And sir, I also worked with L&D in one of the project in Kachi Dargah, Bihar. So where we also came across about 9 to 10 meters of tidal variation in Ganga, and in dry season it's an I can say we can see the tide variation every day, and we have also come across, and we have been seen with I have been closely working with the team of driving engineers and also the L&D and Devo also. In that also we have the pile cutoff levels are below 30 meters from the water level. So in those cases, wherever we have hard soil conditions, what is the equipment what you refer for driving in case of SPD value more than 30 or 40? Because common is vibro hammers, which is 7 to 8 tons, what is available. But what type of equipments do you recommend in clays and in sands?
Yeah. Mostly whenever there is hard strata, as you said, if the SPD value is ranging above 30-35, especially in clay, it almost behaves like a rock. Your sheet pile, your liner may not go. So certain adjustments need to be made to the sheet pile where you can strengthen the sheet pile tip with some additional laminates at the tip so that it becomes a wedge and it can penetrate. You may use an impact hammer also at times, depending upon the resistance that you are facing. Or in the worst scenario, you may have to pre-drill. You can have pre-drills all along the periphery if you are working in ground, and then it will soften the area, and then you can use the vibro hammer and you can drive the sheet pile. And if it is a liner, then certainly you can always pre-drill comfortably, and you can use the vibrator to agitate the area, and you can use some water jets also at times, but with a very controlled, conditions.
Mr. Question from Mr. Ravindra. These cofferdams are retrieved and kept it for after construction or foundation. Retrieved or kept it after construction. So he's just asking in general whether this whatever you have showcased at the case studies. Yeah.
Like I'll give you example of the case study 1 signature bridge, wherein as per the contract allowed us payment for only carrying out such cofferdam work in only one foundation, which was P19, which was a paid item. For other locations, it was not. There was no facility in the contract. So, seeing the performance of the structure, seeing the safe conditions which were created, the client agreed to pay us for the construction of other P3 and P20 as well, even though it was not there. So we could reuse the same material 3 times within the project. So the cost incurred was immediately recovered, and we got additional payment also for that. Similarly, is the case in Narmada, where we could reuse that material for other purposes also. So it is, as a contractor, it is always a value addition.
Correct. Yeah, because sometimes it's better to leave the piles as it is for navigation point of view, giving the piers more additional strength or safety, and sometimes it's case to case. Yeah.
Yes.
That's great. Yes. Thank you very much, sir, for the question and answers as well, and nice insight of what is happening in the industry. And you have taken back to 2010, I think, or 2009 to till now, more or less. And we wish you all the best for future endeavors. And thank you very much for participating in this webinar, sir. Thank you.
Thank you, audience.
Thank you. Passing over to Sindhu.
Thank you, Venkatesh sir. And we'd like to also thank Mr. Ekhlaq sir for this informative session.
Thank you.
So to just brief you about upcoming DFII Groundwork programs, the session 4 will be a technical presentation scheduled on 18th May 2023 at 5 to 6 p.m. And the presentation will be delivered by Professor Prasenjit Basu from IIT Bombay on thermal piles. And session 5 will again be an interactive panel discussion on the topic challenges of working at an underground metro site, scheduled on 15th June 2023 at 5 to 6 p.m. More details will be shared soon. And you can also follow DFII India LinkedIn page for regular updates. So to let you all know, DFII of India is organizing a training program on support fluids for foundation construction with assistance from the European Federation of Foundation Contractors, the EFFC group. So this program is scheduled for 2 days in online mode on 28th and 29th April 2023 between 3 to 6 p.m. IST. So several national and international speakers will be presenting during this program. And the course outline include introduction, types of support fluids, selection and their suitability, bentonite fluids, commercial polymer systems, quality control and sustainability, site equipment and execution, field research study, and Q&A session on each day. So we encourage you to register for this program, and you can visit DFII India website for registration. So this marks end of the session. Once again, we thank the session moderator, Mr. Venkatesh Karmuri, and the presenter, Mr. Ekhlaq, and all the audience for attending. We'll see you again in the further groundwork events. Thank you. Have a nice day.